All right, so we're looking at number 5 of the 2024 AP Calculus BC FRQ number 5 here. If there are any corrections, I will put as a pinned comment below. So the function f is twice differentiable. Values of f prime, the derivative f, are given in the table for selected values of x. Okay, for this, the function is defined by that. Find the value of h prime. Okay, so first I want to find h prime of x, right? Take the derivative of this thing. And fundamental theorem of calculus says I'm just going to plug that x into there, 1 plus f prime of x squared. And then we're just going to plug in pi now. So this will be square root of 1 plus f prime at pi. Replace all the x's with pi. And that's square root of 1 plus f prime at pi is 6. 6 squared is 36, so square root of 37. Okay, seems pretty straightforward for that one. B, what information does it provide about the graph of f? So you understand what this is. This is the arc length formula. You have to recognize that as the arc length formula. So this is the length of f of, so arc length of f of x over the interval from 0 to pi. X equals 0 to pi. Like that. It's just they're just making sure you understand that that is the arc length. Euler's method. Okay, so the way I like to do Euler's method is I make a table here. It's two steps of equal size to approximate f of 2 pi, show the computation. So first is you want, okay, so the way you want to think about it is I like to rewrite this as dy dx. Okay, so therefore dy is equal to f prime of x dx, or think of it like that. Right, where the derivative tells you the step sizes. And so we're going to make a table, x, y, dx, and dy. This is kind of how I like to organize it. There's a lot of different ways to do this. You could write it out as a formula. I like to just use a table here. So we're going to start at x equals 0. And at x equals 0, the y value is 0. So there's there. Now, we want to estimate 2 pi. That means our step sizes have to be pi. Okay? And then dy is literally going to just be the derivative times dx, right? So you're going to take, the derivative is 5, and then the dx here is going to be pi, so this is 5 pi. So that means to get the next value of x, you add the dx, you add the dy to the y, 0 plus 5 pi is 5 pi, and then the dx is the same step size. So now we're saying, okay, dy is f prime of x. Well, x is at pi. So the derivative is 6 times, so that's 6 right there, times the dx part, right? That's going to be pi, so that's 6 pi. And then now we add dx to x, we get 2 pi. We add dy to y, we get 11 pi. And at 2 pi, our estimate is that it is 11 pi. Okay, find this integral and show the work leads your answer. Okay, so this is integral t plus 5 cosine of t over 4. So this is just a general calculus question, unrelated to any of this stuff here. So this is integration by parts, because, well, you could try u substitution, stuff like that. You're going to have an issue here. So this is going to be u. This is going to be dv. And by getting rid of this, I'll just have an integral of some kind of sine or cosine, and that will solve my problem. So u is equal to t plus 5. dv is cosine of t over 4 dt. So du is just going to be dt. Derivative of t is 1. And then v, the integral of this is sine. Derivative sine is positive cosine, so it's positive sine. And then you have to put a 4 in front. Why? Because when I take the derivative, I'm going to multiply by 1/4. That will get rid of that 4. Okay, so then this is going to equal uv, 4t plus 5 sine t over 4, minus the integral of v du, 4 sine t over 4 dt. That's going to be 4t plus 5 sine t over 4, minus, it would be 16 cosine. Derivative cosine is going to be negative, so I want to make this positive 16 cosine of t over 4, like that. And that will be my answer. Oh, don't forget a plus c. I'm going to lose a point for not having the plus c. So just confirm derivative cosine's negative sign, so that will work. And then I'll times 1/4. That will make that 4. So I think that's right. So that looks good to me.